Okay, all right. So today we are going into really the nitty gritty of the unit, okay, which is actually looking at linear equation, meaning straight lines and what they look like in a as an equation and in a table. Okay, so this is gonna take a while. All right. Okay, so let's start. Okay, all right. So today we're beginning really what the point is for this entire unit. Okay, so with slope, rate of change, average rate of speed, and all that is done to set this whole thing up, which is going to take probably about probably 9 to 10 days, all right, of class time, all right, just to finish these three. So the three forms are slope intercept form, the point slope form, and the standard form. And one thing that they all have in common is that they are used to examine what exactly does a graph of a line looks like. Okay, now remember, right, there are three ways to look at, so the magic number in this unit is 3 because there are three ways to look at a line, right? As you remember, the first way is using a equation, second way is using a table, and the third way is using a graph, right, to look at a line. And for each one of these, there are three ways to, so you can do those three views of a function in three different ways. Okay, so the first category is called a slope intercept form, the second category is called a point slope form, and the third category is called a standard form. And we're gonna take about 3 days in each of these forms. Okay, and hopefully by the end you'll be able to convert these, actually recognize them, right? If you see it, you can immediately tell, okay, what form is that? And second is to be able to work with them. Okay, either turn them into graphs or turn them from one form to another. Okay, so it's a lot of different little things that you would have to accomplish. Okay, let's start. Now, in class, I'm gonna give each one of you a graphic organizer. So we're not, and because I see you guys like, once every 3 days, basically. I'm not in a hurry to fill these out, but when I see you, I will definitely give you one, and don't lose this, okay? Because it kind of helps keep your ideas, organized. Okay, all right, so let's talk slope intercept form. Now, the very, very basis of the slope intercept form is actually the formula you use to find a unit rate. Okay, so let me use this graph paper as an example, right? So let's say, right, back in 7th grade now, which might seem a very, very long time ago for many of you, that we used the first quadrant of a graph to set this up. And what we did was, if I were to tell you something, so ignore this for now, okay? What if I were to tell you, right? Actually, this is how I would have taught it, so let's look at it like this. What if I were to tell you, right, and that this is in hours, and this is in miles, right, and we're looking at speed, right, and let's say we have 1, 2, 3, 4, 5, 6, 7, right? And here we have 50, 100, let's say, I guess you're looking at like an airplane or a train, right? And let's say you have this graph, right? And if I were to show you a graph like this, right? Now, first of all, a couple of things needs to be spoken of. One is, right, my first question for you all is, okay, is this graph proportional? So what I'm doing right now is attempting to go back a year, start with what you know, and then start introducing new ideas on top of what you've learned so far, okay? So now look at this blue line here, right? So let's say this is the speed, right? This is speed. I mean, I'm not making this up, right? So if you look at the speed of, I don't know, this car or motorcycle, right? First of all, is it proportional? Yeah, right? Because why? Why is it proportional? It's a straight line, right? Through the origin, right? That's what makes this line proportional. So for example, if you were to examine the graph, it would be 0, 0, 150, 2, 100, 3, 150, right? So on and so forth, right? So these values are all proportional, right? Because if you were to turn them into a fraction, they would all be the same fraction. It'll be 50 over 1, or just 50, right? Now, knowing that, then the next thing is, right, 2. What's the unit rate? Yeah, unit rate is 50 miles. The unit rate, right, which is represented by the letter K, remember that, is 50 miles per hour, right? That's the unit rate. So if I were to ask you, right, and this is hopefully was done in the 7th grade, I would have asked you, hey, knowing the unit rate, what's the equation, right? Y equals what? And back in the day, I would have just told the students, hey, look, you know where the K is right here? Just substitute it with 50. Right? And there you have an equation. So this equation's name, quote unquote, is y equals to 50x. Right? So that's everything you've known so far. So now let's turn back, not turn back the clock. Let's fast forward then, back to today. Okay? Knowing all of that, if I were to say then, all right, let me erase all of this. And then I gotta get rid of all of this. If I were to say, hey, look, let's say we got an equation, right? And what I want to accomplish is this. I want to show you the graph. Now, for this graph, instead of using just the first quadrant, we're going to use all 4 quadrants, all right, for good reason. Let's say we have a graph with 4 quadrants, right? And I say y equals x. Now, think about that right away. What does this even mean, right? Y equals x. What do you think that number in the middle is if we were to have a letter K, right? What would that number be? Yeah, 1. Now, imagine, right, if we replace the K with a different number, and we're going to call that M. In other words, we're just switching letters, right? So we're saying, hey, look, y equals to kx, right? The unit rate. I'm just going to replace the unit rate with slope because I already told you that in the rate of change, right? In the last lesson, that the slope, so the speed, right? The unit rate is the same thing as slope, right? So that's what we're doing here. It's a bit of a sleight of hand in a way, right? We're just exchanging letters because we knew them to be the same, and that is true, right? So K is replaced by M, so that's the slope, right? So that means in this case, the slope here is 1. Now, let's construct the table, okay? Let's construct it the old-fashioned way, right? If you got X, right, that's the independent variable, Y, the dependent variable, and the points. If I were to tell you something like whatever X is, it's equal to Y, because that's what that means, right? So if X is -2, what do you think Y would be? Yeah, -2. And what's the coordinate? -2, -2, right? I'm not doing anything crazy here. If X is -1, what would Y be? Yeah, -1, right? So that'll be -1, -1, so on and so forth. And I'll plot these points, right? -2, -2, -1, -1, 0, 0, 1, 1, 1, 1 actually, oops. 1, 1, and 2, 2, right? And I'll connect the points. All right, so here I got my line. Now, notice a couple of things. 1, right? What do you notice about the slope? Is it positive or negative? Yeah, positive slope, right? So first point we need to understand is it's got a positive slope. Oops, misspelled slope. Right? Second, what's the slope itself? Yeah, it's positive 1, right? The slope is 1, meaning, watch this. Meaning, right, the rise over the run is 1 over 1, meaning you go up 1, right? You go over 1, go up 1, go over 1, you plot a point, you go up 1, you go over 1, you can plot a point, you go up, oops, wrong place, go up 1, right, plot a point, so on and so forth, right? That's the second thing we noticed. Okay, now, you can only see, so right now let me show you what happens if we change the slope. Now, many of you already know that. So what happens when you change the slope? Well, let's see. If you change the slope, all right, let me see how I'm doing on time. Yeah, I'm already getting close to this. All right. All right, so here we got our graph. Now, right off the bat, I think it, because you already learned some of this already. Notice how the line, right, is more slanted. It's a steeper line, right? Now, if this were a negative 3x, that line would go like this. Oops, not the most accurate, although I could fix this. It will look something like this, right? But that's not the case right now. So that's the first thing you need to realize, okay? And I'm going to show you the second thing you need to realize, and this is huge because you haven't seen it yet, okay? So the second thing you need to realize is what happens, right, if I add a number to the end and I name this letter B, okay? Hold on, the light just went off. All right, so let me introduce the concept to you first, okay? So what if, right, instead of just 1x, like how we added here, I'm gonna add a little something extra at the end. All right, so let's take a look at this. What if I do this, right? If I add this little thing here, and what we're gonna do is we're gonna create a table of values again. All right, let's see what would happen. All right, and I want you to recognize it. Let's see. Oh, I shouldn't have done that. This is x minus 2. That's y. That's x, y. Now, also notice, right, in my table of values, I always pick at least 5 values. Okay, 2 negatives, 0. That's huge, by the way. You have to put a 0 in there. I'll explain to you. You'll see in a second. All right, so x minus 2 means negative 2 minus 2. That's negative 4. So that's negative 2, negative 4. Negative 1 minus 2, that's negative 3, negative 1, negative 3, 0 minus 2, that's negative 2, so that's 0, negative 2, and then 1 minus 2, that's negative 1, so 1, negative 1, and then 2 minus 2, that's 0, 0, that's 2, 0. So let's plot these points, see what's up. All right, negative 2, negative 4. Let's see, let me use a bigger point. No, that's as big as I want to go. All right, negative 2, negative 4. So negative 2, 1, 2, 3, 4. All right. Negative 1, negative 3, negative 1, 1, 2, 3. Okay. 0, negative 2. 1, negative 1. And then 2, 0. Now let me connect them with an arrow. This is a little better. All right, so notice, right? Now, first of all, the slope didn't change, right? Notice a couple of things. First of all, if we were to compare the very first graph, the steepness is the same. Look, right? The steepness, it doesn't look any steeper or less steep than the other one. So the slope remained the same. So the slope here is 1, right? There's a 1 here. Now, here's the thing, right? What is different between these two? I should have had them side by side. Okay, all right. Now, look at this one, right? What's the difference between this graph and this graph? Yeah, you notice how this line got dragged down a little, like this? Notice that? Right? Look again. Right? The line here got dragged down. It was here, first question, now it went 2 down. So what does that mean? What does this effect have to do with that? You see this -2 here? That's what happened. That -2 says, hey, you know what? Take that line that was here, drag it a couple of units down. So look at this, right? It was here, 1, 2. So this has a -2 now. Now, this cannot go without being unsaid. Is that how you say this? Right? This cannot go unsaid, right? There's a name for this. This is called the letter B, all right? This is called the y-intercept, which means and is represented by the letter B, which means something like this. At what point, all right, listen carefully. At what point does this line cross the y-axis? Again, at what point does this line cross the y-axis? Where is it? Oh, it's right here. Where is right here? -2. So the y-intercept, again, where the line crosses the y, right? Because intercept means to cut across, right? So where does this line, right, which is y equals x minus 2, by the way, where does this line cut across the y-axis? At -2. That gives us our complete equation, the slope-intercept form. Got that? Okay. Now, knowing that, let's complete. Actually, you know, why don't you try this one on your own, okay? And then you can see if you can give me the formula, okay? All right, so press pause right now. Okay, so this is what I got, right? So if you set up the table of values, you draw the graph, label everything, this is what you'll get. Now, notice, right? At the beginning of it all, the line was here, right? And notice the slope is still 1, right? The slope didn't change here, right? And now I got +3, so what did that do to the graph? 1, 2, 3. It moved up 3 units. Okay, so that's how we got the, okay, that was not a smart question to ask you. I was gonna ask you for the equation. I gave you the equation. That's how you got the line. Okay, right? So now, notice also a couple of things, all right? One last comment. Notice how here, right, 2 things. If I give you this, technically, you can do this without setting up this graph, okay? So watch how you can do that. You see the x +3 here, right? The +3, which means this point already. This itself means that you can start the line at 0, 3. This one suggests that you can start the line at 0, -2, right? Because that's where the line intersects the y-axis, right? So you start at 3. Now, what's the slope? Yeah, the slope is 1, right? So we can just go up 1 over 1, up 1 over 1, up 1 over 1, so on and so forth to create the point for this graph. That's what you can do, actually, okay? So technically, let's do this the next time, okay? You can create a graph completely from scratch without setting this up. You can just look at this and know exactly what to do, okay? So let's start with that tomorrow. Okay, all right, so thanks for watching. This was long, so I'm gonna make it up by giving you like less homework to do tonight, okay, on Delta Math. All right, so thanks for watching. Have a good day. See you tomorrow. Bye-bye.
OMG, that was so good.